tutorial number 8, where we're using Peter Amland's Ursina module to code in Python something that resembles Minecraft. I was laughing because my plan was to have the the Minecraft kind of terrain game open, and I forgot a very basic thing. Right, what I want to show you. I always say this, but this is going to be a quick video, so 2 hours later. But anyway, I've got in mind a quick video. I just wanted to show you this little feature that I coded instead of doing the main thing that I'm supposed to be coding. I'm supposed to be coding or developing the building system, so we can choose what blocks we want to build and things like that, and to be able to like build from the side of blocks or on the top of blocks depending where the mouse is. Anyway, this is where we got to last video. But this is my prepare code actually. I've changed the terrain back to green now that we're coming out of Christmas. Still very much in the winter. In the UK at least, it's a lot colder now. But anyway, this is what I want to show you. Here we go. Check this out. Look how fast we can mine. I'm kind of calling this blister mining in the sense of blisteringly fast. So yeah, I was just experimenting with, like I said, instead of doing the proper development, I was experimenting with different input systems that Ursina provides. And there's one, come to the edge of the world, there's one system called held keys that updates all the time and keeps like track of which keys are held down, hence the name held keys. Which is different to what we've been using so far. We've been using like the little input function, which takes a key, looks at the value of that key, and then does whatever behavior we've coded. Anyway, that's the main thing. I'm going to just show you how to do this, and then you can like just cut through mountains like going through butter. And if I just do this straight down, what's going to happen? You could just go to the centre of the earth. You know what would be a really nice experiment is if you somehow kept track of how far you can go down. I think we still had kind of, yes, okay, that was 63 frames per second for a second. I don't know how to get back up. Let's just walk through the wall there, glitch through. There we go. Anyway, right, let's get to it. Oh yeah, that was right. That's right. I think I still got the aim of the mouse slightly wrong. So let's just run the code from last video. Oh yeah, we're in Blue Ice World, which is kind of nice. So yeah, look, the cursor, I don't know if you can see that, hopefully you can, in the middle of the screen is on that block, and then but we're highlighting a block to the right hand side. And again, so we're kind of shifted to the right hand side, and if I turn around 180, now we're shifted to the left. So you can kind of see what's happening. But we can mine and we can build if we press the other key. Right. So let's come out of there and sort that out. So if we go to the mining system, here we are. We did correctly adjust this line 9 last time. So we've entered the correct player's height. What we haven't done though is X and Z, I'm flooring here, when in fact, because I'm thinking of trying to center onto a block, I'm not wanting to go to the corner of the block, which is what floor will do. It will reduce it to the lowest integer value or whole number value. What I really want to do is round. So if I'm kind of to the right of a block, then it will go to the next block. It will find the next integer value. So if I'm like at 5.5, it will hit block 6. If I'm at 5.4, it will hit block 5. Whereas floor, in both cases, would hit block 5 in that example. Anyway, let's just change those both to round. We don't need to change the Y value, I don't think. But let's just see now if we're getting better alignment. Vote now whether this will work. Here we go. Okay, let's have a look around. That looked pretty. You know what? The Y, oh, is exactly on here. Okay, this is really good. It's not exactly right, but it's, in some instances, it is. I mean, this is precisely on. That's brilliant. Yeah. And if I go down here, okay, so the Y is slightly off. So let's try Y on there. Let's try rounding the Y value as well. I've just got a memory that that didn't work for my prepare code. I could just go and look at the prepare code, but I'm not going to. We're going to do things properly until we don't. Mining system. Oh, there we go. So let's try rounding the Y component of that vector, that directional vector. Let's see if my hunch that it doesn't work. See whether that's right or not. Okay, so it's on that block. That does jump a lot more quickly. Yeah, we're right down onto this block and it's not highlighting yet. So that's off. So, in other words, all I'm going to do is turn that off again. Just say floor, because it was really close to being perfect. And we can look at that later. Let's say, let's just add a little comment for our future selves. This is, or this trajectory is close to perfect. If we can hit perfection one day, I just leave that like an open question. So we know it's, our future selves will know it's something to do with flooring this, and it'll be to do with fiddling around with the 0.5, I'm sure, something like that. Or I haven't quite got the height right or something, or I've missed off a value. Anyway, if you want to investigate that yourself as like a private project, I'll be very happy. It'll be really satisfying to have it always exactly on. Anyway, let's just skip across to the prepare code and just see that it was mining system prepared. Yeah, I've got the Y value floored. This is I times 0.5. I don't remember seeing that in my... Sorry, I've just taken it on a very serious tone. Yeah, so that's I times 0.5. That feels like... Oh, that just means we're going... So what's basically happening here is we're examining 1 block away, 2 blocks away, 3 blocks away, down that trajectory of where the mouse is pointed to go and find the nearest highlighted block. So we start at 1. But that just means I see, because we might want to start... Yeah, if there's 1 block away, or the nearest block is only 1 block away, then actually this examination might miss it. It might go through the block, so we kind of want to start at 0.5. But that means I could potentially... let's have a factor of 2, power of 2. So I go up to 32. So because we're multiplying by half the I variable's value here, we want to double our range. Cool, right. I was going to say, let's not test it and just go ahead and do the blister code, but I better go and test this because the blister code might have its own problems. We don't want to tangle up our bugs. Lovely, that's working. It looks like from the start, have I got the... it's always generating, isn't it, in this version? I forgot. That's another thing we're going to do. Because now if I press G, yeah, it doesn't stop generating. In my prepare code, I've got a little toggle, like I did in the previous series. If we press G, we can toggle on and off the terrain generation, which is kind of handy. Right, and the other thing, the final thing that we're going to do... Oh no, we've got 2 things, of course. The final basic thing we're going to do is see if we can generate the train as fast as possible and generate a big chunk of the train before we get started. And then, another thing, let's show his face now. Big thank you to Guy Nithcrit who's yeah, he said he is also typing along. I think in the previous episode, because I was just changing loads of the dictionary keys, how we structured those, um, and I just wondered if anyone else was like typing along with me because it's a little bit fiddly. So Guy is doing that, and I said we should celebrate whoever's doing that. So Guy, I think we'll go to Blockbench and we'll download a mob. I'm going to try and guess your favourite mob, and then we'll have that mob. I don't know. We'll give it some brains or something. Maybe we could call it. You can name it. So underneath this comment, if you just reply here. Oh no, reply in when I post this video, I guess. So that would be part 8. Tell me what you'd like to call the mob, and we'll call it whatever you like, as a thank you for like typing long, or just as a celebration, a kind of prize. Right. So, what are we doing? Right, we want to do the blister thing so that we can just slice through mountains. Let's slice through this by going to my prepare code and seeing how I've done it. So the mining system, it will probably be in here. Or is it? No, it'll be in mesh terrain where the input is, I'm sure. Here we go. So at the moment, so we're in the mesh terrain module. I'm looking at my prepared version of it. I'll go to our main one in a moment. So when the key is detected as being the left mouse up, so when we've released that key, then we're deciding where the epicenter is of where we want to mine. Then we try and go and mine, and then if we're allowed to mine, then we generate the walls to give the illusion of mining down underneath the surface, and we regenerate the subset model at that site. And that's all there is to it. So what we want to do instead is in the update loop here, where at the moment we've just got go and highlight the block that we're currently looking at. We're going to do this insta-mine, which I think is what I called it when I found it. So let's just have a look. So first we're saying, is the build tool entity actually visible? So that means, are we looking at somewhere where it's viable, where it's okay to mine? If it is, then do the following. If not, you can forget about all of this. So we're trying to be optimal. So we don't want any of this code to run if there's no point in it running if we can't mine there. So then we're running a little loop for key and for value. So I don't think I've done this before, but a for loop where we're going to iterate over this list, you can actually look at two variables, and you just need to separate them with a comma. So in held items, we're looking for, in the held keys.items, which is a built-in thing to Ursina, and that basically goes and gets all of the keys and things that you're pressing at the moment in this update loop. And so it's going to return to us what key is being held at that moment, and also the value. And the value means 1, it is being held, 0, it's not being held, as far as I understand it. Do correct me if I'm wrong. Anyway, so we're just saying, very similarly, we've done all the code for this already, if the key is the left mouse, so not left mouse up, but just if the left mouse is being held, which means its value is 1, so it's being pressed. And then I've just copied and pasted, where are we? Yeah, these 3 lines, 4 lines, sorry, from 54 to 57, and that's where we're generating, where we're just like mining. I guess, because I'm repeating lines here, I should go and write its own dedicated function. However, right, let's try and type all that in. I should just copy and paste, I guess, but so we'll go into our mining system. Nope, we're in mesh terrain. There we go. And we want to find the update loop. There we go, the update function. So I'm in mesh terrain in the update function. So the first thing we need to do is a comment, I guess, which is blister mining. Blister mining. Okay, so first Getting to the right indent block, there we go. If BTE, so our build tool entity, visible, if that's true, then we can bother with all of this. Okay, then we want to say for key, and we also want for value, in held keys dot items. So that's a list of all the keys that Ursina has detected we are holding. And then we want to say if key is left mouse and value is 1. So if we're holding down the left mouse, then we just want to go and copy these 4 lines. And so I guess what I want to do now is write our own function. So I'm going to cut those 4 lines from the input function, and above these 2 we're going to write another class function for it's like instigating some mining. So remember, I'm just scrolling to the top to remind us, this is going to be a class function of the mesh terrain class. I guess it should be part of the mining system. Anyway, we'll refactor that later. Let's put it in here. So we need to be above update, because if update's going to call this function, we need to define the function above it, because we don't have hoisting like we do in JavaScript. Yeah, if you're interested in that kind of thing, look up hoisting. I think that's a term in JavaScript. Anyway, define, we'll call it, I can't think of a better name than do_mining. Now remember, the first argument we must, or parameter we have here, is this, or traditionally self. So that refers this class function to the instance we're talking about, i.e. this terrain. And then we don't want anything else, I don't think. There we go. And now I can paste those 4 lines. Epi equals my, I don't know why I got a red squiggle there. This should be all fine for that. Should be fine to go there. Okay, do mining. So now, firstly, actually I should take care of what I've just destroyed inside the input function. So we're saying that if we've clicked the left mouse button, then I can now say, oh, this, because it's a member function, this do_mining, which it's not liking. Oh, it's probably just because I've left this colon hanging there, hopefully. Anyway, so, this do mining. Okay, some red squiggles have now gone away, except for this guy. Okay, let's go and test that. Oh, mesh terrain is red. I mean, it doesn't like something. Unexpected indent. I bet you've noticed this. What line was that on? Line 39. Oh, right, yeah. It's so obvious now, right. There we go. So epi equals mine. So that basically just goes and works out if we're okay to mine there. Right, that's why I was getting all my red squiggles. So now we'll go back to main. Actually, before we do that, let's go to mesh terrain again. So back to mesh terrain. And is it right down the bottom where we're generating our terrain? Because at the moment, yeah. So down the bottom in generate terrain, so this is where we generate a grid, a block of however many blocks wide we've chosen. Anyway, we're passing into generate block the block type ice. So if we just change that to grass, we should be back. We should be out of Christmas world. Okay. How long I've... Oh, it's already been 20 minutes. Although we have sorted out our... I love how... This is very accurate now. Okay, so first question is, can I blow through this mountain? Let's have a look. Yes. So that's already working, that's good. Feels a little slower than my prepare code, I wonder why. There we go. And interestingly, if you get to the edge of your terrain, then the walls, if you can reach, the walls are going to generate sporadically like this. So you can grow kind of like giant tunnels and things, or bridges of soil, which is kind of nice. Which is kind of like a inspiration, isn't it, for being able to build really rapidly. You could just like spray massive like units of architecture across the terrain. I think that's what we'll aim for. So that's nice. Okay. Oh yeah. What we should go and do is generate the terrain a bit faster, and then generate some terrain at the beginning, and make a toggle so that we can turn off generation, the terrain generation. So in main is where we want to sort that out. Oh, we can also add some fog. Yeah, we should do that. So. What was I just talking about? I've forgotten what I was just going to do. It was... God, what was it? Wish I could rewind the video so I could... So it's something to do with terrain generation. What the heck was it? Oh, make a toggle. So sorry. Right, okay, let's make a toggle. So, yeah, where we create our terrain, after that we'll say generating, that'll be our Boolean variable, and we'll say true, generating true. And then I guess I should call it generating terrain, so we're very clear about it, so we know exactly what we're generating. And then in the update loop at the moment, where we're always generating terrain, we'll say if generating terrain, then do that. Lovely. And I guess, yeah, in input, terrain input. So let's go to the terrain, mesh terrain class module, and we're looking for input. And in here, we'll just say if, oh, no, that we can't switch off generating from here. Okay. Again, maybe I should refactor this later when I'm not as sleepy, but we'll say if key is G, or whatever key you want, we'll say generating equals not generating. So if, generating terrain, isn't it? I think I put that on the clipboard. Lovely. We're getting some wiggles here because input doesn't know what generating terrain is. It's treating it as a local variable. So we need to just use the global keyword here to tell this function that we're talking about generating terrain that's made in this global scope, so we can use it anywhere. There we go. So generating terrain at the moment is true, and now it equals not true. So it's going to be false. If it were false, then it's going to be not false, so it becomes true. So that's a way to toggle something. Right. So let's just go and have a look at my prepare code for the values that I've put in for generating quite a fast terrain. Number of subsets I think I've increased to 1024. So subwidth 6, I was looking at that 5 for a second, 6, and we're going to start with subset 1. That's just because of the building. I think I talked about that last time. We've done the insta-mine. I don't think there's anything else. No, there's nothing else for us to sort out there. So in the mining system is the wrong place. Let's put mesh terrain there. I'm used to having my mesh terrain module next to the main module. There we go, mesh terrain module. And at the start of the class, yeah, we'll have 1024 subsets, and that won't affect things in terms of speed at the moment, but let's just keep track with what I prepared. Anyway, so don't worry about the number of subsets at the moment, but the subwidth absolutely will affect how quickly things can generate. The bigger this number, the slower your computer will run. Because we're creating, well, if you're generating terrain, if you're not generating terrain, you'll have nice silky 60 frames per second. But if you are generating terrain, you've got to balance these numbers, which is what we're going to do now. And what I'm talking about as well is we've got a counter in the update loop. So sorry, I'm back in the main module, and every 4 frames we're going to update the highlighting tool, which at the moment seems nice and silky and fine. But what we could also do is only update terrain maybe every 4 as well. Although we could play around with that. And in fact, what I'm going to do is move the highlighting back to the main part of the loop, so the main indent of the loop. So actually that's now happening every single frame, because that won't be too costly. Also, this number that we're going to fiddle around with is aimed at how often we want to generate the terrain. It has nothing to do with the highlighting tool, so we just want to concentrate on this at the moment. And we could create our own little separate counter that could go up to 4 to optimize that if we need to. But the thing that hits performance is generating terrain here. So at the moment that's happening every 4 times. And what we could also do is write a little loop here. We could say for I in range and then 6. So now if we are generating the terrain, actually I guess I could ask that question up here. We only want to instigate this loop if we are going to generate some terrain anyway. So now we go and generate 6 lots of the terrain, so 6 like chunks of the terrain in one go each update. So that will generate the terrain a lot quicker, but this will be happening as you're trying to move your player. So the higher this number goes, the more it will hit performance. So if I go back to the main, the mesh terrain module, if you keep this number low, you can squeeze in a higher number here. So it's just trying to get a balance. And also, you could the higher this number goes, the kind of better it will be for performance, because this is now only happening every 12 frames, as it were. Anyway, let's copy the values that I've done in my preparation. So I've gone for every 4 frames, generate 4 chunks of the terrain, and the width of each chunk is going to be 6. So 6 times 6 is going to make 36 blocks, cubes, and then it's going to do 4 lots of those 36 every 4 frames. That's right, isn't it? So back to main, so every 4 frames, there we go. And this wants to be 4, doesn't it? Right, there we go. And we've also got our snowfall off. Okay, so it's been exactly half an hour. So maybe we'll forget about the fog until another day, and we'll go and download Guy's mob. Right, so we've got terrain generating, which is pretty fast now, and it's not hitting performance too badly. You can certainly tell that it's not as good as before. But now if I press G, it's really, really nice. Wow, and it's it's really good fun to blister through mountains. I don't know why, but I'm addicted to kind of like tunneling through a mountain, trying to get to the other side. Anyway, I won't do that for too long. There we go. Inside our little cave. Right. Be nice to keep on playing, but let's come out and yeah, so that's fine. I did say, I think there's a very quick thing we could just do. So back in main, still in main, after we've created our terrain object using our mesh terrain class, and we've just got our generating terrain toggle switch there, we could then go and generate some terrain. So we could say for I in range, let's try 128. So we're going to go and make 128 blocks. So terrain dot generate terrain. I think that's all I have to put in there, isn't it? Terrain generate terrain. Lovely. So this will run 128 times. So generating around the player's position 0, 0, 0, a terrain ready at the very start. And then at the end here, I just remembered we've got terrain generate terrain to generate that first block. We don't need that anymore. There we go. Okay, let's just have a look at that. So now, when we press run, this will take a little longer to load. 1 and 2 and 3 and 4 and 5. So 5 seconds, but we've already got a fairly substantial terrain to work with. By the way, just as I walk around, I'll talk a little bit about the future. Perhaps in a couple of videos' time or something like that. Actually, I can't really predict, but in upcoming videos, we'll be writing the code for how to save and load terrains, which I've already done in my previous series, and I've done with this new mesh terrain. I've just got to work out the simplest and the best way that works. And then what we can do is, at the very start, aim to load a really massive terrain as quickly as possible. That's pre-saved, pre-prepared in a save file. That's a little odd. Were we at the edge there? Oh yeah, we were at the edge, perhaps. Like I say, my mining doesn't seem to cause any problems. Another thing I'll just talk about while I'm wandering around, I think I've kind of mentioned this before, but the way we're kind of like mining here, like blister mining, this is like a demonstration of what we could do behind the scenes to create mines. So in other words, we just have an automated algorithm to do what I'm doing here. So like pick a spot, a position on the 3D landscape, and then just go through these iterations, these for loops in random directions, or using some just climb up the wall there, sorry, not trying to, using some Perlin noise or like a random walk to generate caves. I'm kind of feeling in the back of my mind also, or thinking about in the back of my mind, it'd be nice to have some kind of like giant creatures that go around and just create mines and caves and other features and bridges and things like that. So you actually see the terrain developing and evolving by wonderful creatures and things. That would be really nice. Anyway, just a thought. If you have any thoughts like that, do share them, of course, in either the comments underneath the videos, or on the issues page on the GitHub repository. That's where you can get all the code and all the assets, by the way. Link is in the description to that. Right, Guy, let's go and try and use Blockbench in 10 minutes. Here we go. This is for you, Guy. Okay, so if we go to blockbench.net, I'm very nervous because I haven't used this in a long time. So open the web app, or you could download it, you know. We want to go, oh yeah, so first just what key binding, I'll just go for default. And what do we want to go for? If I go for Minecraft skin, I think I can, we can pick from like a list. So where it says model Steve, we can go down here. So I want to pick something for Guy. What would he like? Last time, in the last series, we had a giant chicken called Vincent. So we can't have a chicken, I guess. I like a ghast, a hoglin. Actually, I don't play enough Minecraft, so I don't know what a lot of these are. Polar bear, pufferfish, ravenger, skulker, shulker, sorry, not skulker. Snow golem, that sounds pretty good. Slime, I think a slime, isn't that just a cube of like slime? A villager, a witch, a wither. Wither sounds good. I think a panda. I think we're going to go for a panda. Right, that's exciting. I'm very excited now about panda. Okay, so we'll go for panda. Resolution 16. I can't remember how to do this. Layer texture. No. Texture. I think what we wanted to do... Oh, right, so you can go... Oh, you can go and select textures automatically. Layer texture. I thought there was going to be a texture template. No, I don't know what layer texture is. We'll leave that blank and then just confirm. We've got a panda. Let's try make him look a bit pandery. So on Blockbench here, up on the left hand side, you've got the skin. So you can texture it. In the middle here, oh right, you press your right mouse button to translate it, up, down, left, right. If I press Command, nothing happens. What about Control? Nothing happens. Shift? No. Mouse wheel is obviously zooming in and out. What if I press my mouse wheel? No. No. I'm trying to find rotate. Is it Control? No. Whoops. Oh, if you don't hit the model itself, left mouse button is rotating. So there we go. Rotate, zoom in and out, and right mouse button to translate. Cool. So I've given him like a mask accidentally. Let's paintbrush. I need like white. This just looks like a cow. It's like panda cow. I can't remember. How would you make a what are the patterns on a panda anyway? I can't remember. I should have got some reference images. Are those eyes too big? Oh God. Black. I think those eyes look okay. It kind of looks like a pig. It's a pig panda cow. Oh God, I just scribbled over its snout. I pressed Alt Z and that took me somewhere else. What are we doing? Right, okay. Okay, we'll just commit to a black snout, black muzzle. It's not a snout, it's a bear, so it's a muzzle, isn't it? Lovely. you suddenly realise why texturers get paid so much. Okay, belly. We'll have a secret pink belly. That just went black. How do I undo? Command Z didn't work last time. Anyway, okay, we'll have a black belly. It looks very scary, which is not what I was going for. And this isn't even white. This is kind of like a grey. I really enjoy my commentary, by the way. It's just me complaining about me. There he is. Although, okay, I've got an idea. This is going to rescue everything. Toenails, right. We've got to make the eyes look, somewhat approachable. That looks kind of, no, we can't have pink eye. We can't have pink eyes, can we? We've got to have like that, and then oh, I guess that looks like he's kind of like laughing. That looks kind of okay. And then if we get white again, there we go, around like that. And let me just pause the video for a moment. Let's pause. And I've hopefully unpaused that. Oh, and his bum. I'm just going to leave the bum alone. Oh no, he's got yellow back feet. Okay, we'll leave yellow. No, I can't be so unprofessional. We've got to have black. We'll go for black. There we go. And oh, up here, by the way, you've got fill mode. Sorry, I'll just do this very, very quickly. There we go. And I just don't want kind of like the default colours. I've left some yellow somewhere. Oh, I could just go on. No, don't do that. How do I undo that? Edit, undo, close tab. No. Is there an undo? Oh, edit, undo. Edit, undo. Yes, there we go. Fantastic. Okay. So I think if I had face on it, it treated this whole thing as face or something. I don't know. Right, okay, we've got a cow panda. I'm happy with that. Oh, blue ears. No, we want no, I don't want pink on. We'll have white ears. White, lovely white ears. And a white snout. Muzzle. Okay, it looks a bit more bear-like now. Okay. So, we've got a panda. So what we want to do now is export this so that we can use it in Ursina, our Ursina project. So if we go to export, we want to export it as an OBJ, an object model. And what that should do is package in our texture as well. I think that's already downloaded. So let's just open a new tab on my file explorer thing. There it is, assets number 2. There we go. So if you unzip that file, you've got a model, an MTL file, and a panda PNG. So I'm going to rename the model, because that's a bit generic, to panda mod, and panda PNG will rename to panda text. So panda underscore text. There we go. So if I copy both of those, copy those 2 items, and inside our main project folder, now we can go to our assets folder, and in here, I guess we could tidy this up later. We haven't got too many things, but we'll paste 2 items in there. And what I mean by tidying this up, we need like a subfolder in here for sound, subfolder for textures, subfolder for models. We'll do that in a future episode. Right, so we've got panda mod and panda text. So let's go back to our code. Thank you to Blockbench and to Guy, Hypocrite. Here we go. Right, so we could do this in main, but we shouldn't. We should have our own module to do this, but I can't think clearly right now, so I'm just going to do this down here. But we will at least leave ourselves a comment. So mobs deserve their own module. So we're going to say, at the moment, we'll just call it Guy. Guy equals new entity. Remember, do tell me what you'd like your panda to be called, if it exists, if this works. So model equals, and now we can reference panda underscore model. You don't have to put .obj in. Ursina will find it for you. I'll put it in anyway. No, sorry, I'll take it out just to try to prove that I mean. Texture equals panda underscore text. Obviously, you might not be using a panda and your file might not be called this, so obviously call it whatever you've called your mob. So that should now be in our world. It should already be working. We've just got to look at the scale and the position. So at the moment, it'll just be in the middle of the screen, as it were, or the world, not the screen. So we could just say guy.position equals, so that's going to be a vector 3, the position, so it's x, y, and z location. We'll say equals the subject position plus, and we'll say subjects forward, so that means whatever direction the player is facing, the subject is facing, that's what dot forward will mean. And we can say times 7, and that'll put Guy 7 units away from us. Hopefully about 7 blocks away, and hopefully there won't be anything in the way. Anyway, right, let's go and run it. Do we have a mob in our terrain? Running. I'll have some coffee. Maybe he's in the sky. I'll just turn off generating terrain. Anticlimax. I don't see our panda, our nameless panda anywhere. Hopefully I've just forgotten something obvious. I want him to kind of be here. Oh, I need a system, that can display to the screen what position we're currently standing in. Right, so that's failed so far. Okay, let's just have a quick look. Model, panda model, texture, panda text. It'll probably be to do this. Let's create ourselves our own vector, and we'll just say 0 on the x, 7. No, we don't want to be. We want to be about 2 on the y, and then 7 plus 7 on the z-axis. And vec needs to be a vector 3. There we go. Let's just have a look at that. Now, if we still don't see our nameless panda, we'll try increasing the scale. You'll find when you import models from different places, they'll have like different scales. So he's either inside here. Oh, I guess I could just blister away some of the mountain. He's either inside here or he's in the sky. Oh! There he is. He's really high. So 0 right up there. It was kind of pink. Anyway, so position wants to be about, I don't know, minus 20. Let's run again. Does this mean I just buried him somewhere? Oh, this is very imprecise. Right. Guy position. Okay, I've got a clever idea. Okay, right. Will that? Oh, no, okay. That won't work. Let's just say -4. This is awful. Trial and error. My clever idea was to just, when I press a key, we can move our nameless panda in front of the player. I don't see him. Right, let's make him giant. So it's easy to spot. So guys.scale times equals 10. So 10 times as large. Now the danger in making something very large, a model very large when you're trying to find it, is that you could find yourself inside the model and then you don't realise that you have found him but you're inside of him, which may be the case right now. So I'm going to run over here. Just in case. Well, he doesn't seem to be... Is he underneath? I did see him before, didn't I? When it was... I saw him in the sky, and then I tried to move him down. Oh no, we're heading to an hour long. Oh, did I just see him? No. Maybe it was just something... It wasn't the cursor that I was looking at, was it? Surely not. And it did look kind of red. This would never have happened with Vincent. Vincent was always very well behaved. Okay. Okay, this is, yeah, the guy's position, 0, 0, 0. Well, that will happen anyway. Scale, we won't go crazy, just make him 3 times as large. Just in case, maybe we blew him up so large I wasn't out of him yet, I don't know. But we know where he is. He's going to be where the player spawns. And he isn't there. So, I must be doing something wrong. So let's try putting obj panda text.png. I won't do anything with this scale. But the thing was, I'm not getting any error messages into the console. Or was I? I didn't really have a look, to be honest with you. So, in one sense, the fact that he hasn't suddenly appeared is good news. It means that we don't have to put obj and png on there. Let's just have a look here. So these errors are just to do with the fact that I'm using a Mac. Oh, there we go. Missing model. I didn't read the console. Missing model panda model.obj. So what that means is I've renamed it to something slightly different. Panda mod. I am so sorry. But well done. Congratulations if you saw what I was doing. What on earth did I think I saw in the sky? I was just looking at the cursor, and it looked like a little fox to me, but it was just a square to everyone else. So panda mod. Let's take off the obj. Now I'm actually really excited because it really should work. So let's put that 7 ahead of us. Maybe try -3, and then leave the scale as it is, and then run and have some coffee. He's there. I thought for a second he wasn't. Yes! And the scale is about right, isn't it? Right, so if I move him back, you know what? If I just move him back, so that should be a 9, we'll go 10, and then actually we'll put him minus 2.9, should just be above the ground, and the nameless panda for Guy will exist in our world. Yes, I can't wait to learn his name. Here he is. Hello. We've got a panda. We have a panda here. This is wonderful. Okay, right. Let's end this video here. Oh, just before an hour. We did it. We did it. With our blister mining. There we go. We can put the nameless panda on a pedestal. Lovely. Thank you very much for watching, and I'll see you in the next video. Goodbye.